Hello students, in the previous class we finished number system and now we'll start the second part, which is indices. You can see on the screen the laws of indices. First law, a raised to m into a raised to n is equal to a raised to m plus n. Okay. Here the base is a, okay, and power is m and n. Okay. Suppose my a is 5. Okay. So my a is 5. So 5 raised to 2 into 5 raised to 3 is equal to 5 raised to 2 plus 3, which is 5 raised to 5. This is what I want to say. Correct? I'll just prove it. What is 5 into 2? 5 into 2 is 5 into 5, right? And what is 5 and this multiplication sign? And 5 and 5 raised to 3 is 5 into 5 into 5. So 5 is 5 times, correct? So this is 5 raised to 5, right? So with this I prove the first law, that is if a raised to m into a raised to n, a raised to m plus n. Okay. Similarly, second law, a raised to m upon a raised to n is equal to a raised to m minus n. Okay. So the second law, suppose 5 raised to 3 upon 5 raised to 2 is equal to, it said that 5 is 3 minus 2, which is 5 raised to 1. 5 raised to 1 is 5 only, right? Okay, let me prove this. Okay, 5 raised to 3 means 5 into 5 into 5, and 5 into 2 is 5 into 5. So 5, 5, 5, 5 cancel. What is remaining is 5. Right? So I proved you all the first law, the second law. Okay. Now this is the third law. A raised to m the whole raised to n is equal to a raised to m into n. Okay. So suppose 5 raised to 3 the whole raised to 2 is equal to 5 raised to 3 into 2, so which is 5 raised to 6. Okay, this is what I'm trying to say, right? Okay, how much is 5 raised to 6? Just calculate. 5 into 5 into 5 into 5 into 5 into 5. 1, 2, 3, 4, 5, 6. Yes. 15,625. 15,625. So 5 raised to 6 is 15,625. Let's calculate this. Okay. This is 5 raised to 3. 5 raised to 3 is 5 into 5 into 5, which is 125. Right? So 125 raised to 2. So 125 raised to 2 into 125. It comes to 15,625. 15,625. So see, LHS is equal to RHS. So that means this and this is equal. Right? Okay. So proved the third law as well. Next law. A into B the whole raised to m is equal to a raised to m, b raised to m. Okay. Let my a is 5 and let my b be 3. Okay. So a into b raised to m. Let my m be 2. Okay. Is equal to 5 raised to 2 into 3 raised to 2. This is what I'm trying to say. Okay, let us check. Now this is 5 into 3 is 15. 15 square, right? And how much is 15 square? 15 into 15. It comes to 225. 225. Okay. Now what is 5 square? 5 square is 25. 3 square is 3 3s are 9. How much is 25 into 9? 225. So this also we have proved. Okay. A into B the whole raised to m. That means A raised to m into B raised to m. Okay. Now the next one, which says nth root of A raised to m is equal to A raised to m by n. Okay. So here I can't prove it exactly. Suppose now I'm writing 5 square. Okay. No, not 5 square. Suppose I'm writing square root of 5. Square root of 5. Okay, this I can write it like this also. 5 raised to 1 by 2. Okay. Or if I want to write cube root of 5. This I can write it as 5 raised to 1 by 3. This is the way of writing. Okay. I can't prove it. Okay. But this is the other way to write it. Okay. Square root of 5 can be written as 5 raised to 1 by 2. And cube root of 5 can be written as 5 raised to 1 by 3. Okay. So, okay. Now, if I want to write like this, 5 square cube root of 5 square. Okay. So 5 square is 5 square as it is, and cube root I can write like this, 1 by 3. Okay. So here this is A raised to m the whole raised to n, which can be written as A raised to m into n. So which can be written as 5 raised to 2 into 1 by 3. Correct. 2 into 1 is 2. So which is 5 raised to 2 by 3. Okay. So what I mean to say is, if nth root of A by m, A raised to m is given, so n is the denominator of the power. I hope you get my point, what I'm trying to say. So if square root of A is given, so it can be written as A raised to 1 by 2. Okay. If suppose A raised to 3, it is A raised to 3. If square root of A raised to 3 is given, it can be written as A raised to 3 by 2. Okay. Because the square root sign is 1 by 2 and cube is as it is. Okay. The minus sign will not come. It's not a minus sign. Okay. And anything raised to 0 is equal to 1. Okay. If 5 raised to 0 is equal to 1. 7 raised to 0 is equal to 1. Anything raised to 0 is always equal to 1. Okay. Now, the seventh law says A raised to minus m is equal to 1 upon A raised to m. Okay. What I mean to say is, suppose I am writing 1 upon 100. 1 upon 100 can be written as 1 upon 10 square, because 100 is 10 square. And 1 upon 10 square can be written as 10 raised to minus 2. Okay. This is also one of the law. All my students need to write all these laws in the book. Okay, you don't need to prove it. I just tried to make you all understand how we came up with these laws. That's it. Okay. Now, before starting with the problems, some formulas you must know. Okay. The formulas are, I'll write all the formulas which I'm sure you have already studied when you were in school. Now, a plus b the whole square. What is the formula? A square plus 2ab plus b square. This is the first formula. Right? Do you want to know how it is derived? It's not important though. I'll just show you how we came up with this formula. Now, a plus b the whole square means a plus b into a plus b. Right? So when you open the bracket, it is a into a plus b into a plus b. Right? How to open the bracket? First a into the whole bracket, then plus b into the whole bracket. Right? Okay. Now, a into a is a square plus a into b is ab, and this plus sign as it is. B into a is ab plus b into b is b square. B square. Right? Now, 1ab plus 1ab is 2ab. So, a square plus 2ab plus b square. This is how we have come. We got this formula. I'm so sure you all have studied this in your school. We don't have to derive the formulas. I'm just revising y'all how we came up to this formula. Okay, anyway, we don't need this. Okay. So this is the first formula. Second formula, a minus b the whole square is equal to a square minus 2ab plus b square. Okay. Now, when you open a minus b the whole square means a minus b into a minus b. Okay, if you open the bracket, you will come to this point. So, that is how we have come to the formula. Okay. Like when you do a minus b into a minus b, eventually you will get a square minus 2ab plus b square. And that's how we have come to this formula. Okay. The next formula is third one. A square minus b square is equal to a plus b into a minus b. Okay. So if you simplify this, finally you will come to this. If you want to do it, you can do. See, a into a minus b plus b into a minus b. Okay. A into a is a square minus ab plus b into a is ab and plus minus b into b. Plus into minus is minus, right? And b into b is b square. So minus b square. Here plus ab and minus ab cancel. So what is remaining? A square minus b square. Okay. So this is how the formula is derived. You don't need to know how the formula is derived. And it's very simple. Actually, you must know how the formula is being derived. Anyway. Okay. So these are the three formulas. The other formulas are a plus b the whole cube. So Fourth one, a plus b the whole cube. A plus b the whole cube, the formula is a cube plus 3a square b plus 3ab square plus b cube. Right, this is the formula. Okay, so here 3ab is common, right? It can be written as a cube plus, as 3ab is common, a plus b cube. So yeah, this can be written this way as well. Okay, so when you see this, okay, 3ab is common, 3ab is common, so 3ab I have taken out. So out of a square, 1a I have taken out, 1a is remaining, this is the remaining one, and here 3ab square, so 3ab I have taken out, only 1b is remaining, so this is that b. Okay, next formula, a minus b the whole cube. A minus b the whole cube is a cube minus 3a square b plus 3ab square minus b cube. Okay, so yeah, this is the formula. Okay, and similarly the way you wrote the above, same way, a cube, what is common? Minus 3ab is common. What is remaining? A minus b is remaining. Okay, minus b cube. Why I am writing a minus b? See, minus minus makes plus. Okay, so minus plus is minus, minus minus will make it plus. How this formula is derived? A minus b the whole cube will be a minus b into a minus b into a minus b. Okay, if you open the brackets, finally eventually you will come to this point. Okay, and a plus b the whole cube means a plus b into a plus b into a plus b. Okay, and when you open the bracket you will come to this point. So you will need all these formulas. Okay, so I want you all to copy all these formulas. And the last formula is, no, there are two more. A cube minus b cube. A cube minus b cube is a minus b, a square plus ab plus b square. And yeah, this is the formula. Okay, let's see whether this formula is right or wrong, because I have my doubts. Okay, now I'll take this side and I'll just keep on simplifying. Let us see if I get this at the end. So a into a square plus ab plus b square minus b into a square plus ab plus b square. Okay, this is a cube plus a square b plus ab square minus ba square minus ab square plus into minus minus b cube. Yeah, a square b, a plus minus cancel. Yeah, what is remaining? A cube minus b cube is remaining, right? So that means the formula is right. Okay, the next formula, seventh one, a cube plus b cube is a plus b into a square minus ab plus b square. Okay, let us check this whether this is true or false. Okay, so a into a square minus ab plus b square plus b into a square minus ab plus b square. A into a is a cube minus a square b plus ab square plus ba square minus a b square plus b cube. Okay, so no, it's not correct. I didn't get it right. ba square minus ba square. Yeah, ab and minus ab. Yeah, it's correct. A cube plus b cube. Yeah. So a cube plus b cube is a plus b into a square minus ab plus b square. Okay. So you might need these 7 formulas, okay, while solving the problems. Please take down all the 7 problems in your notebook. It's very important. So today you are supposed to write 7 laws of indices as well as 7 formulas. These formulas, very important. Okay. Let's solve the first problem. Simplify. Okay, so the first one, is, the first question is 10 into x raised to 3 upon y the whole raised to 2. This you are supposed to simplify. Okay, let's simplify this. So square is for 10 also, for x raised to 3 also, and for y also, right? So 10 raised to 2, x raised to 3 raised to 2, y raised to 2, right? 10 raised to 2 is 100, x raised to 3 the whole raised to 2 is x into x raised to 3 into 2, which is 6, upon y raised to 2, which is 100 x raised to 6 upon y raised to 2. So this is the answer. Okay, the first one. Second one is 5 raised to 5 raised to 0 plus 5 raised to 2 raised to 2. Okay, so yeah, let's solve this. 5 raised to 5 raised to 5 raised to 0 can be written as 5 raised, it is as this is this only, okay, it's same. So 5 raised to 5 into 0 plus 5 raised to 2 into 2, which is 5 raised to 0 plus 5 raised to 4. 5 raised to 0 is 1 plus 5 raised to 4 is 5 into 5 into 5 into 5, which is 625. So this is 626. Okay. So next problem, the third one. 5 x raised to 2 upon y the whole raised to 4. This is 4. Okay, so I'll open the bracket. So 5 raised to 4 x raised to 2 raised to 4 upon y raised to 4. So 5 raised to 4 is 5 into 5 into 5 into 5, which is 625. X raised to 2 raised to 4 is 2 into 4. 2 into 4 is 8. And y raised to 4. So this is the answer. Okay. Next problem, fourth one, is a raised to x plus y into a raised to 2x minus y. Okay. Now here it is as good as a raised to m into a raised to n. Okay, base are same. This one, a raised to m into a raised to n, that is a raised to m plus n, right? The first law, it is as good as that. Okay, this is m and this is n. Okay, so which is equal to a raised to m plus n. So x plus y plus 2x minus y. So plus y minus y cancel. So a raised to 3x. Right? What did I use? A raised to m into a raised to n is equal to a raised to m plus n. I used this law. Okay. Let's solve the next one. X raised to m minus n into x raised to 2m plus 3n. Okay. How can I write this? X raised to m minus n plus 2m plus 3n, right? A raised to m into a raised to n is equal to a raised to m plus n. I'm using this first law. Okay. Fine. Where this is my m and this is my n. So let's solve this. X m plus 2m is 3m. 3n minus n will be 2n. So x raised to 3m plus 2n. This is the answer. Okay. Let's solve the next sum. Okay, this is the question given. Cube root of x square, the whole cube, the whole raised to 1 by 2. Okay, so let's do this. Now cube root of x square can be written as x raised to 3 by 2. Correct? And then remaining I'll write as it is. Okay. Now I'll remove the bracket. So it will become x raised to 3 by 2 into 3. Okay. The whole raised to 1 by 2. If I remove that bracket as well, it will become x raised to 3 by 2 into 3 into 1 by 2. Okay. So this can be written as x raised to 3 3s are 9 upon 2 2s are 4. Correct? Oops. No. Wrong. This is not right. Wait. Here only I made a mistake. This is not right. Now it is cube root of x square, right? So x square will remain as it is, x square upon 3. Right? X square upon 3 and cube root, and then 1 by 2. This can be written as x raised to 2 by 3 into 3 into 1 by 2. So here 3 cancel, 2 cancel. So this is only 1 is remaining, right? So x raised to 1, which is equal to x. Yeah. Okay. Let's come to the next problem. X raised to 1 by 2 plus y raised to 1 by 2 into x raised to 1 by 2 minus y raised to 1 by 2. Is it a plus b, a minus b? Yeah. See, if this is my a and this is my b, so this is a plus b, a minus b, right? So a square minus b square is a plus b, a minus b, right? So yeah, so how I can write this? A square minus b square. So x 1 by 2, this is a square minus b square. So this is a and this is b, right? So I'll just write the formula here. A square minus b square is equal to a plus b, a minus b. I use this formula and I'm writing this. Okay. Now this can be written as x 2 by 2, which is 1, y 2 by 2, which is 1. So x minus y. This is the answer, x minus y. Okay. Okay. Let's do the last problem for today. Raised to n plus 1 plus 2 raised to n minus 1 upon 2 raised to n plus 2 raised to n plus 2. Okay, so let's simplify this. Now 2 raised to n plus 1. Okay, so now 2 raised to n plus 1, I can write it as 2 raised to n into 2 raised to 1, or raised to 1 I don't need to write also, right? I can say this. 2 raised to n plus 1 can be written as 2 raised to n plus 1 can be written as 2 raised to n into 2 raised to 1, correct? Because a raised to m into a raised to n is equal to a raised to m plus n, right? So this is my a raised to m plus n, and this is a raised to m into a raised to n. Similarly, 2 raised to n minus 1. Now 2 raised to n minus 1 can be written as 2 raised to n upon 2 raised to 1, right? Because a raised to m upon a raised to n is equal to a raised to m minus n. Here n is 1. Correct? Okay. So So 2 raised to n plus 1 can be written as 2 raised to n into 2 raised to 1, which is 2 only, plus 2 raised to n minus 1 can be written as 2 raised to n upon 2 raised to 1. Okay? Upon 2 raised to n plus 2 raised to n into 2 raised to 2. Okay, raised to 1, I don't need to write it. 2 raised to 1 is the same, right? So here 2 raised to n is common. So I'll bring that out. 2 raised to n is common. So uncommon thing is 2 plus 1 by 2. Okay. Here again 2 raised to n is common. So 2 raised to n, I'll bring it out. 1 plus 2 raised to 2 is 4. So I can just write 1 plus 4. Okay. So now 2 raised to n I can cancel. So 2 plus 1 by 2 divided by 1 plus 4. So I'll just take LCM. 2 into 2 is 4. 4 plus 1, 5. So 5 by 2 upon 1 plus 4 is 5. Okay. So this is 5 by 2 upon 5. Okay. This can be written as, now if A upon B, the whole upon C upon D, this can be written as A upon B multiplied by, instead of C upon D, you have to take the reciprocal, D upon C. So here when I am writing 5, that means it is 5 upon 1. Okay. So when I multiply, so it would be 5 upon 2 divide by, instead of divide I'll multiply, and denominator I have to take the reciprocal, so 1 upon 5. Okay. So 5 and 5 is cancelled. So what is remaining? 1 by 2. That's it for today, students. Have a great day. Thank you very much. I want you all to practice. Okay, you need to practice this a lot. Okay, make sure your basic is strong. You need to make your basic strong for this. Okay, and this comes only with practice. Thank you very much, students. Have a great day.